8 foot is 24 inches, 27 and 30 inches. 7/16 minimum, where the others been 3/8, so you're already using 7/16 typically. So 2 anchor bolts, and this here is where it's going to require, if you're going to cast in place L bolts, you can't use just the cut washer that comes with that. You have to use, it's a bearing plate. It's this one requires 2.5 by 3/16. Ours is a 3-inch, and so you have to use that with the nut that comes with the anchor bolts. But they're requiring, they're counting on all this bearing here to help resist the racking over of that. So that's why you'd have to have some bearing plates there.
So it's going to be the same anchor bolt we're using in the other type of quarter frame?
Yes.
Well, so it's same length and same 60 inches or 15 inches length?
Well, typically they'll, this one here is just gonna require 7 inches of embedment into the concrete. So half-inch L bolt, half-inch anchor bolt with 7 inches of embedment. It's typical sill plate anchorage on that one there. The other one where it was triple sill plate, you have to get a 15-inch J bolt or post-install small thread epoxy for that one, because we currently do not have 5/8, and we've got extra long ones in a 1/2 inch, but we don't have the long enough in the 5/8. I think we actually we should be coming up with one of those, but most people are using all thread epoxy. Yeah, it's all thread epoxy is usually what they'll use there, but that again for the PFH method is going to be, you can see that here, it's 5/8 inch diameter. So if you're getting L bolts for the front and they're just sending out 1/2 inch, it's got to be 5/8 for the PFH method. For the rest of these here, it's just your standard 1/2 inch L bolt, 7 inches. Let's see, this one here, the use, I don't know why that's not all showing. The length is 1.5 times the length. So if you have 8 foot height there, 24 inches, 1.5 times that length, that 24 inches now counts as 36 inches of bracing. So that's what you get on that one there. So now your continuous sheath portal frame method is the one that I really see very little of, just because well, one requirement, you do have 16 inches, 16, 18, and 20 inches based on plate height. That's as narrow as that can be. And I'll show you the drawbacks to it, because a lot of people see that, well, 16 inches, well, I like that one. I don't have to use the whole gown, but there's a huge drawback to that. 10 foot maximum top of the header. Everything else is the same, 3/8 on this one instead of the 5/16. Sheathing nailed, 3-inch grid pattern. Same thing. 1,000-pound strap, same thing. Splices occur within 12 inches of mid height instead of 24 inches. It's on a foundation, 2 anchor bolts with 2 by 2 by 3/16. We don't have a 2.5 and a 2-inch and a 2.5 inch bearing plate. We just have a 3-inch. Of course, the same plus, so helps with any confusion out there. So the big drawback with this one is why would I use PFH method if I can't, if I don't have to? Why could I not? I have 16 inches. Why can't I use this one here? Because it only counts as the length. If you have 16 inches, that's all it counts for. You have 16 inches and 16 inches, that's only 32 inches. No wall line is allowed to have less than 40 or 4 feet of bracing. So no matter what wall line you have, computer may print out or spit out that, I only need 2.3 feet of bracing. You would have that with that method, but it's also going to go a little bit further. That calculator goes a little bit further, and at the end it says 4 feet. Because no wall line shall have less than 4 feet of bracing. So that's why this one's really never used. You don't have enough bracing. You're going to need at least 4 feet, a lot of times 6 feet of garage, so you just can't use that. You may be able to use it You can't use it throughout the house and have some benefit there, because more than likely the rest of the house, a lot of times you're gonna have enough spacing without even having to use a portal frame method, but other requirements make you have to use that method as well in distances, and we'll go over that when we go over the plan.
Let's say that one is an end panel of a continuous wall, and you have this portal frame, and it is less than 12 feet and 6 inches. You have a continuous wall, and the end panel is less than 12 feet and 6 inches,
Mhm.
and you are turning it to the CSPF.
Mhm.
In that case, can you count
Can we count?
as not just the 16 inches, just 12 feet or whatever it is, the total length of the portal frame? Are you with me?
This will count as a panel in your brace wall line, yes, if that's what you're asking.
So there is no.
You're probably not gonna see
there is-
this used very much in a garage, but you might see it used on a patio,
Right.
Yeah, not the garage, no.
Yeah, you'll actually see it in the plans when we.
or on a back
I'll
wall,
show you this
on
one.
a back wall.
With a bunch of
And
windows.
You've got a bunch of windows over here, and you're using that, you're gonna use that as part of your panel, part of your bracing, if that's what you're asking.
Yes, but is there any requirement as far as the span of this?
Oh, yes, yes, yes. In this chart here, we actually have for the PFH method, that's a very good point, glad you brought it up. PFH method, minimum of 6 feet opening from edge of panel to edge of panel. So 6 feet to a maximum of 18 feet between this first panel and the edge of that panel there. No less than 6 feet, no more than 18 feet on a PFH method. You go to the portal frame garage and then the CSPF method. They are both 2 feet to 18 feet. So they're all no more than 18 feet between panel edges, but the minimum changes anywhere from minimum of 6 feet for the one with hold downs, and then minimum of 2 feet the other. Is that what you're asking there? Okay. And like I say, you'll see it more here whenever we go to the plan.
I think it says in the code also, minimum header length is 22 feet, or maximum. Maximum, 22 feet, I think.
I think that only shows that for the CSPF method. I don't know if it's for the others or not, but it specifically says it at the CSPF method that, yeah, your header can only be 22 feet long.
If we have over 22 feet, then we need to go to the previous method, which is the BF.
Well, no, again, it only shows it in, I think,
Let's say you have a wider garage span, so what do you do in that case? So
if you have a wider span, you end up having to go with a different method. Engineer, not necessarily an engineered beam, because it says the header, it doesn't say engineered 2x or what, it says your header cannot exceed 22 feet on, and it just says that on the CSPF method. It doesn't say that for the others, so I don't know if there is, that would be up to the designer who you'd be getting your lumber through to let them span it and see what they're spanning, because they're gonna know, they're gonna be able to span it for.
22 feet is a clear span, yes?
Is what?
That is a clear span, yes?
That's from end to end, there's not in between, not open space in between, that's from the end of the header to the end of the header. So that's, 18 feet is the minimum, or is the maximum of that opening can be. So you've got another, 2 feet on each end. So we will talk about, now where do they go? We know what the brace wall panels are, now we'll talk about where do the panels go, maximum brace wall panel spacing and the locations of them. In 2000, before 2009, it was, all the bracing in the code book was based on seismic design. Well, in 2009, they broke it out to seismic and wind. And actually, the builders took one on the chin for that because seismic, you can see here, if you're just looking at continuous sheathing method, 1.4 feet of bracing needed, 1.5 feet of bracing needed, 2.7, 3 points. So you're needing a little bit more bracing when it comes to wind as you are with seismic. So, but they broke it out into 2009. So, it says exempt for seismic here, you're exempt for seismic requirements, if you're in seismic design category A, B, and detached buildings in C. So we are in, for seismic, we're in seismic design category B. So seismic design category B says you don't have to use this requirement. You're governed by wind, you go to the wind requirements. So some of the wall bracing, the effects of wall bracing, you talk about ridge heights here, is that this is the amount of bracing that's required when you have a shorter eave to ridge height. But when you add height here, there's more wind acting on that structure there. So the higher the eave to ridge height, the more bracing you're going to need there. So we're going to go into more of the exceptions and things like that. So here's your seismic design category. This is all B, and here's some C right here from Oklahoma City, Lawton, down that area there. So we're seismic design category B. We're white over here. That actually says 90 off to the side. I don't know why that's not showing. But the so we built to seismic design category B, 90-mile-an-hour winds. And now the amount of bracing is all based on a starting point in the code. So your starting point for 90-mile-an-hour wind is based on what story you're actually working on. It's based on exposure category B, the 30-foot mean roof height, 10 feet eave to ridge height, 10 feet wall height, and 2 brace wall lines. So if you have less than 30-foot eave to ridge height, or less than 10-foot eave to ridge height, 12-foot wall, and 4 brace wall lines, you're going to have adjustments in there. So the code book tells you all the adjustments, but this is the jumping off point, all these parameters right here. So with these parameters here, you have, let's say, that our, here, we're going to use this example here. We have 40 feet in between our brace wall lines in the side-to-side direction. We've got 40 feet distance there. So if we have 40 feet, if you're going to use the lead-in bracing, you're going to need 12.5 feet of bracing on that wall. If you get all the way down to continuous sheath, you need 6 feet of bracing because it's rigid. It doesn't require as much bracing. It's a stronger method there. So you're going to need 6 feet of bracing. But again, that's all from this chart, all based on this information that's over here.
For 3 stories, I'm sorry, you go level by level here based on this IRC codes. So let's say you
well, if you're,
calculation on the
if you're first of 3-story, you come down here. And you would use this one down here. So if you're 40 feet, 40 feet on first of 3-story, 40 feet wall spacing, lead-in bracing is not permitted. You go from needing 12.5 feet to 35.5 feet. You get to continuous sheath from 6 feet. Now you need 17.5 feet.
So the first story on a 3-story would be 17.5 wall brace. The second floor would be 12 and 6.
How do we attach to the second floor to the first floor on the wall brace lines? Is there any sort of detail for that?
I don't think there's nothing detailed, but it would be the same as, I mean, it's usually stripes. I mean, you're gonna.
There's no code for that. Is there building
Yeah,
code
there's,
for this?
we've got here at the beginning where we had,
Bill, the city has any requirements about attaching the second floor to the first floor?
800-pound hold down fastener
They're
to the
there.
foundation or framing below.
Okay.
You know, that's special corner.
That's
framing.
just corners.
No second alter that passes from the first to the second.
I don't know what code would
It's,
have.
it's another one of those, like these outside straps are gonna be outside of the sheathing,
Mhm.
so it's very tough for me to inspect because the sheathing's already up. But yes, there should be. on
But you
second
know,
story.
you are connecting your sill plate to the slab because 6 feet, you put 5 feet center to center J-bolts. And when you go to the top plate and build another
Mhm.
floor on top of that, you are counting on the nails to be able to transfer the shearing load and
Right.
tension load to the first floor
Right.
just by the nails.
Yeah, there's supposed to be some.
Yeah,
straps
because you
tied to
could,
the
you can have your sheathing, attached floor to floor, but you can't use it for shear and for uplift. So if you're using your sheathing for uplift, you're gonna have to use some attachments for the shear, whether that be hold downs from floor to floor or screws. We've got some extra long screws that go from floor to floor, that you can, do that, with. But, typically, what you'll see is they'll have sheathing from floor to floor, but they'll also have straps for the uplift. So, that's typically what you'll see, and I don't know what requirements are from the code and how much capacity those would need to be. Okay, so, let's see, so here are all the adjustment factors on paper. So the paper is gonna tell you number of stories, you're gonna have this, increase, you're gonna get, hit 50% increase on that one there. If it's, eave to ridge height of less than 5 feet, where you start off at 1, now, because it was a 10-foot height, see here is 1 is your 10-foot height, anything less than that, you got a 30% reduction. Or if it's over that, you got a 30% increase, or 60% increase. So these are all the adjustment factors that you can go through by hand and figure it all out, or use calculators.
Say it again. Just say that again, please.
So, yeah, when you go back to this one here, this was your jumping off point. This is considering 30-foot mean roof height, 10-foot eave to ridge height, 10-foot wall height, and 2 braced wall lines. So, if you go on to this one here, is what if you're under that jumping off point, that starting point? What if you're under that? Well, you get reductions for those, and they're based on, see, exposure category B is 1, so anything over that, you're getting hit on.
Nice.
Anything underneath the starting off point is that you're gonna get reductions for. So it's either an increase or a reduction. And wind exposures are based on exposure category B, if you're in a residential area, or even if you're the first house in a residential area, no trees around or anything. The code assumes that you can still call that category B as long as there's gonna be structures around you, same size, type structures around you. I think within 5 years, I think they actually go out that far. So, you know, it's not that you bought 100 acres, you're putting your house on 100 acres, you know, with nothing around you, then it's different. You go to exposure category B, or to exposure category C, which you may get some C, but most of them are gonna be B, most categories. And then you can go up to D as well, coastal and inland, extends over water per mile, or, you know, and all that. So more adjustment factors, eave to ridge height, again, anything under 10 feet, you're gonna get a reduction on, anything over, you're gonna take a hit on. I'm gonna go through these fast so we can go over the plan. Adjustment factors for wall height, same thing. Number of braced wall lines as well. The number is based on 2. If you go to 3 braced wall lines, you're taking a 30% increase. So it's kind of one of those, there's a wash, because there's also one for spacing, for braced wall line spacing. Anything less than, the 30 feet or whatever it was. The more braced wall lines you have, the more you're getting penalized. But they're getting closer together, so you're taking a reduction. So it's really just a wash on those. So, adjustment factors is under, top, so it's saying, this one here is that if you're using, a hold down, you can actually take a reduction on some of the methods you can actually take a reduction on if you're using hold downs on every brace wall panel within that wall line. No one does that, it's just added cost and you don't ever need to do that. Because it's still cheaper to build a PFH method than it would be to put a bunch of hold downs on every single panel on that wall, just to get your.
You know what we do in our homes? Beside of covering all requirements, the code for manual forces and bracing, we are using Simpson strap, H4 Simpson straps.
For your rafters.
For the rafters and also start to the top plate and start to the bottom plates. Because
You do it for stud top and stud bottom?
every other studs,
Every
top
other.
and bottom, but all the rafters to the top plates.
Okay.
We made sure they could be able to properly transfer the load from one to the other. But this is why I asked you about the second floor, so what happens when we have brace along two walls, top of each other, so is there any, if there is not, then in that case, we are going to stick with one of these straps.
So I've got a flyer for you that I can go over, with you afterwards. And it talks about the continuous load path and how you can build to resist either an F0, F1, F2, because you can build to resist up to 135 mile an hour winds. We've got details of how to do that, whether you're doing every rafter and then every other stud, or every stud, or floor to floor and header to top, and header to studs. We've got all that information that I go over.
Is this requirement in the other state, like California? They're using those?
Continuous
area
load
straps?
path, California has, all their homes are engineered,
Yeah.
so there's no really residential requirements for that.
You're gonna get more so like if you went to Florida.
Florida, every house is engineered. Coastal areas along the Gulf Coast, it's all engineered, and that's what they're doing, is continuous load path. Tying their rafters to the top plate to studs, stud to bottom plate to foundation. Some are using rods to where it bypasses the studs, it's just a rod from the concrete all the way to the top of the top plate.
That's
You still have to do your, rafter to top plate there, but yeah, I've got some information on that to go over with you. Gypsum board, there's a reduction there. No case shall the minimum total length of bracing in a brace wall line after all adjustments have been taken be less than 48 inches. Brace wall line placement. So the amount of brace, it's based on the amount of bracing required, the spacing between the panels, and placement at the ends of the walls. So, for the amount of bracing, you've got each of these segments here has to actually qualify as a brace wall panel. You can't just say, oh, that's 9 inches right there, it doesn't count as a brace wall panel, but I'm counting it as bracing. It has to qualify as a brace wall panel in order for you to count it as bracing. So, all of these sections here, A plus B plus C plus D, is the amount of bracing that you have. So, the brace wall panel spacing, so these panels here are 25 feet on center. And measured center to center, and you're talking about possibly just 2 feet in. So if you have that's a 6 foot wall here, like in our example here, you're saying 2 feet in from there?
I'm gonna give them every benefit of the doubt on
Yeah.
such spacing.
Yeah. Okay. So as long as you're not 30 feet apart, you can't do that. If you're 25 feet, say you're 25 feet in between panels here, then you can't do that because then they're too far apart. So 21 feet in between panels is a good estimate there.
And did you say this brace wall panel is 16% of
No.
the total?
No, that's what I'm saying is, that's off the board now. It used to be easy where you can just say, the amount of bracing required here, I just need 16%, and I can figure it out in my head, and boom, I'm done. Well, I didn't in my head, I still have to just calculate it. But now you can do all of this just by the paper that we just showed you, all those adjustment factors, and figure out how much bracing is required. StrongTie.com is, I'll show you the calculator. We won't have time to go through all of the calculator, but I'll show you the calculator and then, and show you the plans here. Intermittent method only here for where your brace wall panel has to be in, regards to ends of the wall. A plus B less than or equal to 12.5 feet. So your first brace wall panel here, has to be within 12.5 feet from each end combined. To where when you go to continuous sheath, that can be 12.5 feet, and that can be 12.5 feet. So you have a benefit of doing the continuous sheath method that everyone's doing already with continuous sheathing. You know, but once you start using in some fiber board or pink board or things like that, if you're just using intermittent method and using 4-foot sheets of OSB, it's an intermittent method, and you have to be 12.5 feet combined. Designing around problem areas, garage fronts, narrow walls, great rooms. Again, this is what I was saying at the beginning, is how I go about doing it is I possibly redesign the house. It may be shrinking the window just a little bit, or moving it over just a little bit just to get it. If you can't do that, hiring an engineer is an option as well. Sometimes their methods are more expensive than having to go through an approved alternate. But
An engineer, does that mean to be a licensed engineer or?
They need to do something and stamp the plan.
right. Yeah. So, so where the building does not meet code, it's saying that it can be, or portions of that part of the building do not meet code restrictions there, requirements, is, so a great room, again, that wall, if your great room is 30 feet wide, 20 feet tall, you don't have a brace wall panel within each side of that to qualify as a brace wall panel. So you would have to go to an engineer to get, you can just get that section engineered, that wall engineered. You don't have to do the whole house. So you can do just that wall if it falls out of restrictions of the code. And pre-engineered solutions are, again, they're code evaluated, and the city still, even with ICC, they still have the option to not allow that. But at least from a manufacturing standpoint and from a building official standpoint, they know it's tested. And it's up to them to still approve, because approved equal, anything in the code says or approved. Approved means by the building officials, so within that jurisdiction. So typically, if they have a code report, then they're good with that. So not all manufacturers have code reports on all products. So they have to be aware of that if you're going in to use any of our products or a competitor's product, just to make sure that it does have code compliance.
Just to say something on that, and that goes with everything, you know, there's new products coming online all the time, whether it's house wrap, sheathing, roofing, whatever it is, you know, as long as we can get a report on it and it will meet what the requirements of the code are, I'm okay with doing that.
Yeah.
Unless we just discover it's really a bad product or something.
Yeah, I mean, so it tells you again all the scope of it for 2006 IRC and IBC. It gives you a bunch of information on that. So if you go through all of these and you don't have any solutions where you can use PFH method or one of the other methods, you go to an engineer. If you don't want to go to an engineer, then there are pre-engineered solutions that are code approved. The steel strong walls that we have they can replace anywhere from 2 feet, really up to 6 feet. 8 feet in some instances, but for the most part 6 feet. So we've got those available anywhere from 12 inches. So no, the narrowest you can go prescriptively is 16 inches with PFH method or or CSPF method. Either one of those you can get down to 16 inches. But sometimes you do have less than 16 inches to do with, especially at garages. You know, a lot of guys only have 12 inches, some may only have 9. If you have 9, you're SOL altogether, unless an engineer can really come up with something, because there's no manufactured wall out there that goes under 12 inches. There are some walls out there that are 12 inches. Ours is 12 inches and actually comes with the stud. Comes with studs attached, one stud on each side, and it's true 12 inches. Others are 12 inches of steel, plus you have another 3 inches there, so you have to worry about that as well. But you can get down as narrow as 12 inches on that. Okay, so let's pull out the plans here. So now that we've got them marked up in your wall lines, I always start from the front, again, work my way back in side-to-side direction and figure out where am I going to get my bracing. And I tell you, we're not going to get through this whole thing, so we'll try to get through the side-to-side direction. Front to back is pretty easy. But from the side-to-side direction, I always start here at the front, working this way here. I've put it into the calculator, so, and I've already got these. I want to try to get the calculator pulled up and show you how to do that. If not, you guys can give me a call and I can come and show you guys how to use the calculator. That's no problem at all. Go over designs with you guys. I offer that to anybody. Craig's taking advantage of it, so we'll work on all their plans. We do the same thing for you guys. So it's show you guys how to do them. And but anyway, for this one here, I know that this brace wall line here, by what I put into the calculations, was I need 4.22 feet of bracing on this wall line. So how the calculator works is you're going to put in your eave to ridge height. You're going to put in your brace wall line spacing first, your eave to ridge height, your plate height, what method you're using, whether you're using continuous sheath or chipboard method. And then it's going to ask a couple other questions in regards to what you put in for your method. You may not have to put anything else in. But then it comes back and tells you how much bracing is required. So I know that there's 4.22 feet of bracing needed on this wall line here. So now I have to figure out how I'm getting that bracing. I've got 18 inches here, 18 inches here, and then I can't remember what I have here. I've got 10.5 feet on this. It wasn't to scale, so I was guessing on some of it, but it got pretty close. But either way, we've got this area here that we can work with here, because I've got 18 inches. Okay, so the first one is I use continuous sheath method. Do I have 4 feet of bracing? Do I have 4 feet anywhere? 4 foot sections. But I don't have that. Next one with continuous sheath, you can do partial credit. Do I have 42 inches? Okay, do I have 3 feet? Okay, so I don't have any section that has any of those. So my next one is, okay, I've got maybe an alternate brace wall panel. I can use the ABW. I know that my minimum was 2 feet 4 inches, so looking at this sheet here, the ones that are stapled together, you can look at it and say, okay, on an 8-foot plate height here, I need 2 feet 4 inches. Do I have that? I only had 18 inches on each side here, so you kind of narrow down. What you're going to end up doing, try to narrow it down to as narrow as you can get. So what are my next methods then? So can I try CSPF? But you can try CSPF on an 8-foot plate height. You know, a minimum of 16 inches is required. Well, I've got 16 inches. So I've got 16 and 16, that's 32 inches. Does that work? I needed 4.22 feet of bracing, so that doesn't work. So that's when you would look at this section over here and see there wasn't 18 inches, there wasn't 16 inches, there's really nothing I could do at that corner to get a brace wall panel because it's less than 16 inches. So it's one that you can send my kids to college and put a brace wall, a steel strong wall there and there and there, and get all the bracing you need, but you just spent $1,000. You know, you don't need to do that. So CSPF isn't really an option. Four frame garage, is that an option? Because 4 frame garage, you can put, for an 8-foot plate height, you need 24 inches. You only had 18, so that doesn't work there. Again, sometimes that will work. You have 24 inches there, you still wouldn't work. if you had 24 inches, that would work, because 24 inches is just 4 feet, you need 4.22 feet, so that's why I really always revert back to PFH method. Skip all the guesswork and saying, oh, okay, is this gonna work, and this gonna work, and go through it. I just go with PFH method. I mean, it's easy, and not that expensive. Covers you on pretty much every application, and, saves red tags, so. And once you're red tagged on these, they're most always a very expensive fix. So you might as well get it right up front. So, because it's either engineered or it is, steel strong walls that are, anywhere from $360 up, so it's, it can't get expensive there. So for less than $100 worth of material, you save yourself a headache there. So what I ended up doing, I mark it with PFH, I circle and put PFH on there, just so that you have to know what, buildings to know what method you're using to get your bracing out of that 4.22 feet. Whenever you go in and put put the information into the calculator, you have a chance to save it or create a PDF. I do both. If you save it, you can actually bring those plans back in, and so you're building the same house, but you change the wall height, 9 feet instead of 8 feet. You can just change the plate height there and don't have to put all that other information in. So you can import your plans back in there and do it that way. For the calculator, whenever you're putting that information in, go ahead and print it off and have that with your plans, because that tells Bill that he can, I don't know how thoroughly he looks at them, or if it's just spot checking, but, because you're putting all the parameters in. And if you're putting that you've got I'm gonna fudge this one, so I don't have to use as much bracing. I'm gonna use that I've got 9 feet of eave to ridge height, when actually you had 20, It's a way to spot check and make sure that you have that. So that would be required as well as part of your documents. Do you require that? Okay. Most people that are actually doing plans will actually require that, because that lets him know how much bracing is needed on this wall line, and then you have to provide, circle these here. So we'll go on to this next one. Again, I went all the way through. These are where I'm putting my brace wall panels. All of those right there. And I mark this CSWSP, CSWSP, CSWSP for continuous sheathed wood structural panels. And then this one here, I just mark GD. I don't know what you want them to denote what they're actually using there to get their bracing?
Well, the main thing is they need to identify that brace wall line. In other words, out there to the side, you're gonna put brace wall line 2-1. And then you're gonna put either gypsum board, or you're gonna put continuous sheathing, you're gonna put whatever you're using to brace that. And that calculation has to be on the most restrictive, okay? In other words, if you're using continuous sheathing, you have to use all continuous sheathing. You would have to put continuous sheathing across the backside of the garage. But if you can get enough bracing there, you may be able to go gypsum board, but it's gonna ask for 20 feet of bracing, where the continuous sheathing may only ask for 6 feet, okay? But just mark that you're wanting this much gypsum board, we need this much footage, and then we just see that you get that much.
And so for the next one, is this back wall here. You actually had 22 inches, I believe. You have 22 inches on this section here, 24, 24, and then 22. So you can base that on 22 inches there. I don't have enough bracing there to require, because it's a continuous sheath method. I don't, it's based on the height of the the opening and wall. You're going to need 30 inches, I believe. So to count this as a brace wall panel, you need 30 inches. So you only have 22, 24, 24, and 22. So you don't have enough to meet it there. So you know you're gonna have to do one of your portal frames. So you figure out which one you can use there. This one, you can use the CSPF method. on that one, you have 22 inches, and I think 16, 18, and 20 inches, I believe is what it is. So you've got enough there for that one, so I count that and mark it CSPF. And then the next one here is continuous sheet. You have 6.5 feet of continuous bracing. On this wall line, all you needed was 9.4 feet, and you've got 6.5 feet there, and you've got 22 to 22. You've got your amounts needed. So you don't. This one here, so here is less than 25 foot on center from this panel to this panel. So you're good to go there. There's three things to remember when you're doing your brace wall lines and putting your panels in. Is that, one, do I have enough bracing? So this one, yes I did. This one, yes I did. This one, yes I do. The next one is, are my panels within 12.5 feet from each end? And it's right on the end, and it's right on the end, so yes. The next one is, are my panels less than 25 feet apart, 25 feet on center apart? So those are the three checks. Do I have enough bracing? Are my brace wall panels compliant with, in regards to the end, 12.5 feet from each end, or each end combined, depending on the method? And then, are my panels less than 25 foot on center apart?
Question.
So the next one, just one sec, we'll get this last one here. This one only needed 4 feet of bracing on that wall. So you've got more than enough there based on your height. 5 foot opening on a 8 foot plate height is, I think you needed 24 inches, yeah, you need 24 inches, and you have 54 inches on each side. So one, you've got enough bracing, you're within 12.5 feet from each end, and they're less than 25 feet apart. So you're good to go there. The front and back directions are always the easiest. There's not many offsets, and there's no windows or anything like that. So for that one, I just kind of circle in there what panels I have, and just all of these are CS, WSP, continuous sheet with structural panels. And that's how I do those. If you have a question?
For the side-to-side bracing, what if I take with same equation, same analysis, take the CS pH panel out, if I have enough wall on the other wall, just stick with the same calculation, don't redo the calculation with the new wall brace line, skip that one and just stick with the minimum amount I have.
Right.
Yeah, I guess I have.
Yeah, you have
don't
enough,
do
right.
anything about that, the patio, the covered patio walls.
Right.
So just leave it the way it is, without going through the
Yeah.
CSP.
Right. You
Can I
can't,
do that?
you cannot, because you don't meet the three requirements. The three were, do I have enough bracing? Well, you did have enough bracing there, but just say that was, you only needed 6 feet of walls, for this whole wall, and you had 6.5 feet. Say that panel there qualified as enough for the whole wall line. So you could say, yes, I do have enough bracing for the whole wall line,
But you can only go 25
but the
feet.
second one is, I'm not 12.5 feet from each end. Because this is my first brace wall panel, I'm 12.5 feet from here, but this side of that panel is more than 12.5 feet from this end right down here. So you can't do that. Your first brace wall panel has to be within 12.5 feet from each end. So you can't do that. And then, they're not 25 feet on center because you don't have enough of them within 25 feet of the end of the wall. So that's the three rules, the three things that you have to check. Do I have enough bracing? Am I 12.5 feet from each end? And are they 25 feet on center?
What if I just skip that wall and have it, and take this brace wall line out and just combine the very last one, which is the master bedroom wall, with the dinette and second bedroom walls together, and have another brace wall line. If the calculation shows that that's okay, and since they are not over 60 feet apart, so
You're talking about combining this wall with
Yeah.
this wall,
And
and then just have this one on its own?
just Just don't count the brace wall.
You gotta count that though.
You have to count this as a braced wall line because it's an
outside
exterior
wall.
wall. Every exterior wall has to be part of a braced wall line. You can't just ignore it. Yeah, I see what you're saying. If this was from here to here was less than 6 feet, you could say that this is all one wall line. That one, and that one would all be one wall line. And you could possibly ignore this area here if it's really less than 21 feet, and that was a panel, and that was a panel. So.
Remember your chart on the back that we gave you, okay? That'll tell you if you can count that as a panel. You got 10-foot heights, ceiling heights on that. You got 6 foot or 60 inch.
Right.
So you gotta have 30 inches wide panel to be able to count it towards bracing, okay? And we didn't have that much between those windows.
Right.
So that was the reason why you had to go to the continuous sheeting portal frame. Now you can count that little panel on the side towards bracing, and you can count that as a bracing within your 25 feet on center.
Right, one more question. For the wall back to the second bedroom dining room, for that one, if you use the hold down, I don't know how far is the window from the corner. I can
This one here?
Both of them, the other one, bigger.
For this one here, you only have 28 inches. That's what that, right.
I don't have,
What's that?
we do have the,
You have 28 inches. You can't count this as, you got 24 inches here, yes.
so I can,
But that 24 inches has nothing to do with anything right here because it's not at the end of the braced wall line. The 24 inches for your special corner framing is here and here, because those are the ends of your braced wall lines.
and the wall between those two windows is cannot count it because it is less than.
The one between these two windows is, you really can't count this one because when you're looking at your elevations, there's a plate change here. It goes from 8 foot here to 10 foot here. So that space in between there, instead of having 42 inches in between there, or whatever it is, I think that was like 42 inches in between there. Well, now it's broken down into 12 inches and whatever, 3 feet, whatever it was, because you have a plate height here and a plate height here. So you can't count that all as one there.
If I didn't have that one, so I could be able to count that.
Well, yeah, you can still, I mean, if this was no plate height, offset here, that can be a braced wall panel, that can be a braced wall panel. This cannot because you don't have enough room. You can resize windows or move them down a little bit or whatever, but still, you're not within 12.5 feet. This panel here is not within 12.5 feet from the end. So you still have to address, no matter what you do over here, you still have to address the first braced wall panel has to be within 12.5 feet from that spot right there. No matter what, no matter what.
We're out of time. Sean, thank you very much. You did a wonderful job. Appreciate it. Rick's Crib, anybody wants to come on down. Barbecue's on Bixby today. Yeah.
Thank you. If you guys have any questions, here's some cards here that you can always give me a call and I can work with you on your plans and, any issues you may not have.